Hello, LinkedIn. Today we're not on site inside an automotive manufacturer. Instead, we're visiting EJOT, as it's pronounced. Jake and Steve are expecting us, so follow us inside. I believe they should be waiting for us, so follow me in. Oh, there's a doorbell here, actually. Let's press that. Here we go. Come on in. Steve,
how you doing?
Good to see you again.
All right.
Jake, how we doing?
All good.
So thanks for having us. Shall we take a look at what EJOT does?
Absolutely.
Yeah.
Sweet.
Follow these guys, shall we? Very nice building. Come on in, come on in.
See you guys.
Thank you very much. Oh, nice. Okay, look at this. So, yeah, what does EJOT do then? Tell LinkedIn.
Indeed. So we're a fastener manufacturer in a lot of industries. So we do right the way from construction all the way through to automotive and a lot of different applications in between. Fixings is exactly what we do.
Okay.
Mechanical fixing most components and weird and wonderful components together. So yeah, what I can show you is I can show you some of the technology that we've got and some installation machines.
Yeah,
and then we'll see what they do.
Yeah, cool. Let's go take a look, shall we?
If we have a look here, this is kind of like the bread and butter of the technologies. Again, we're using the DPRAG units. In here, what we use is the analysis for what the customers require.
Okay.
So, anywhere where you're fixing components together, we need to do the torque analysis so we can tell the customers exactly where their installation torque should be.
Yeah.
So all the materials we're looking at, just before we looked at the RSD, we're looking at fixing a piece of plastic part to it.
Yes.
There's bosses here that we can fix back to it within cars, anywhere in automotive, where components are so thin that you need a boss. Yeah, so we can fix into the materials. We're fixing into aluminiums. We're fixing into sheet material.
Oh, yeah.
So thin materials, thick materials.
Wow.
Again, plastic materials. We're looking at, I mean, there's one component there. That would be a camera for anything really. Reversing camera. And if we're looking here, we're looking at the fastener that's holding the components together.
Oh, yeah.
So what we'll do with this machine is, with all different parameters, we'll do installation torques, So we'll destroy the components, and then what we'll do is we'll get graphs, then we can give these graphs over to the customer, discuss exactly what they require, and give them tightening torques for their application. So we're essentially destroying the materials to see exactly what fails, where it fails, how it fails, and then we can advise them the best fastener to use and give them the results that they require. So we can move on.
Yeah.
We'll move to the FDS machine.
Okay.
So this is all about flow drilling technology. Yeah. And
Come stand next to you.
essentially what we do here is, if anybody knows about flow drilling, it's essentially putting two pieces of aluminium together. Yeah.
Yeah.
You're talking sheet materials. Yeah. So what flow drilling does, it doesn't drill, it doesn't remove any material, it flows the material.
Right.
Specifically, because again, lightweight construction, thin materials. So what we essentially do is we'll flow thin material to make thread forming into thicker material. So using 1 to 1.5 mil, as you can see, we'll install and thread form into the flow of the aluminium. So changing 1.5 into 2 mil. Therefore, you get more thread engagement into the material. Therefore, you're getting better performance in the material. Therefore, you're getting better clamp load on the parts what you're joining together.
Wow.
Yeah. So again, that's quite a nice piece of cross section.
Oh, nice. Yeah,
where you can see the flow drill. You can see the amount of threads engaged.
Yeah.
Again, all different types of material, all different types of aluminiums, different thicknesses. But flow drilling's the kind of technology where we are with joining aluminiums together. Yeah. Using their adaptive machine, I can do an install for you just to show you the flow drill. How simple it is to do. So I'll just come around here.
Yeah, sounds good.
So it's quick, as simple
Wow.
as that.
Yeah.
Again, it's all about parameter settings, but once we've got them right, we can actually make sure that the joint's secure. You can see the nice flow driller material there.
Yeah. Wow.
Yeah, which
Made
is,
it look easy.
nice. It does. Yeah, very easy, but again, a lot of analysis behind these machines. And then what we can do is we can talk through the customers on the graphs, see where the angle is, see what speeds they're looking at, see what torque they need to hit on the installation.
Wow, yeah.
And that's what it's all about. It's like making sure that whatever mechanical joint's been fixed together, that we make sure that the customer understands, along with the machinery, that they've got everything they need for their processes.
Fantastic.
So, yeah.
Thanks for showing us that.
Next machine, I can pass you through to Jake.
Jake, yeah.
And he's got the air weld machine, yeah.
This is what we call the air weld machine. So as Steve's already talked about, we are a fasteners company, so we normally just do the fasteners. So the machines that you've already saw before is nothing that we actually make. We use other companies for that.
Sure.
This is the only machine that we do actually manufacture with the fastener itself.
Oh, okay. Wow.
Okay, so here's the machine over here. It can be on a pedestal, as you see, but it can be fixed to the end of a robot, mainly in automotive industry with that. And the basis behind this is we're joining dissimilar metals. So it's in the automotive world, lightweighting is the way to go.
Yep.
So a lot of aluminium is used, but to get that strength, they use the high strength steels. So to join those dissimilar metals, we use friction welding, which you've seen a lot over there. This is another type of the friction weld with that.
Wow.
Again, it's a very quick process. It takes roughly half a second to a second, depending on the materials. We have a few different kind of elements that I can show you.
Yeah.
We have our SRE elements, which is for thinner aluminium top sheets that we would do. So it's got a smaller head height.
Oh, yeah.
Whereas if we turn it around, we've got the bigger CFF, which is more for your thicker aluminiums. We can do aluminium to aluminium, which is this top one as well.
Okay.
So it's using the same sort of element, same head style as the CFF, with only a small imprint on the other side.
Oh, yes.
All the others minimal on the underside. And composite materials we can go through as well with a pre-hole.
Oh, wow.
I'll fire it up and we can have a look.
Yeah, sounds good. So Jake is just working his magic down there.
So if you want to go around, we'll do that.
Yeah, sure. Where are we looking? This part here, yeah?
This bit, sorry. So if you look around here, and it will be pretty quick, you'll see it move down and come together.
Okay, here we go, guys.
Off it goes, careful your fingers.
Wow.
Like that. There we go.
That is impressive.
Just be careful because that will be hot. It is a type
I
of
won't touch it then.
friction weld with there, but you can see around the top, so it all joins it together,
Yeah.
and that's roughly about 1.4 millimeters head height with
Wow.
that. And yeah, if we have a look at the screen, all that 4 steps in 0.91 of a second.
Wow.
Right. So this is our generation 2. We've got it set up for the SRE element that we've got here.
Yeah.
This is our older type of machine, our Gen 1,
Okay.
which has got the other type of element, the CFF,
Yeah.
for those thicker bits of aluminium. It's just because we have to use different equipment for the different elements to feed them and things like that.
So this is the newer one behind us, and
yes. Here we have the Gen 2.
the guy that started it all here.
Yeah, and a sneak peek. Keep an eye out. There will be Generation 3 coming in the next year or two.
Oh, okay. You heard it here first. Wow. Just like that, eh?
Some parts here, some destruction testing.
Okay, yeah.
So we're looking at how good the weld is to the boron. So what we'll do is we'll go through rigorous testing here to make sure that the parameters are correct.
Yeah. That one's been put through it.
It has indeed, yeah. Essentially chisel test, yeah. Big hammer,
May
big
I?
chisel, and yeah, of course. So what we do is we actually separate the components together to make sure that we've got the weld. If we don't see the big or the large nuggets coming out, then we know that it's failed.
Oh, okay.
So
Yeah,
what we'll
yeah,
do is we'll go back, and Jake will go back, parameter settings, tweak them, and so we get the best results essentially.
Fantastic. Okay, brilliant. Thanks very much for showing us that.
Thanks.
So, how do we get out of it?
Right behind you, this way.
Okay, well, thank you very much, Steve, Jake. Good to see you. Thanks for showing us around. Really appreciate that, and we'll see you guys at the next event.
Indeed.
Okay, cheers. Take care. Let's go, guys. So that was EJOT. Very, very exciting stuff in there. It's fascinating to see all that kind of stuff, in person. Normally at our events, they have a desktop and we see a few bits, but here we got to see how they actually make it, what they do, their full brochure of what they do. So, yeah, thanks for watching. See you next time.